1 and 2, all right? Number 1, well, the first step in factoring is GCF, so greatest common factor, right? All right, so looking at just the numbers first, we have 13, 39, and 26. What is the GCF for the numbers? 13. Okay. Now look at each of your variables. So I have x squared, I have x cubed, and I have x to the fifth. Which x comes out? X squared. And I know an x comes out because every single term has an x, right? Okay, so now let's look at the y. I have y cubed, y squared, and y to the fourth. Which y comes out? Y squared. Okay, so my GCF is out, so then I have to open parentheses, and then that means I'm dividing every single term by my GCF. Right? So now, let's see, what do we have? 13 divided by 13, 1. X squared over x squared, 1. Y cubed over y squared gives me what? Y. Okay. All right. Let's look at the second one. 39 x cubed y squared divided by 13 x squared y squared. 3x. So plus 3x. Good. And the third one. So negative 26 x to the fifth y to the fourth divided by 13x squared y squared is what? Y squared. Good. Perfect. And then you can stop there. All right. So here's what it's all a lot of on the homework. If you guys can take a GCF out, but you can't factor anymore, right? Say you have a trinomial, right? We wanted to break down the trinomial, but if you can't, then you're done. You just stop here. We don't call it a prime though. Okay, I saw a lot of primes on your papers. If you can factor anything out, like a GCF, then okay, you do that and you stop when you can't factor anymore, and then you're done. All right? Prime means you just can't do anything. There's no GCF, there's nothing. Okay? All right, so let's look at number 2. How many terms do you have? 4. Okay, so 4, I go, all right, this is the one where I have to divide it in half. But first step in factoring is GCF. So if I look at the whole thing, do I have a GCF? No. Okay, so then let's divide this in half. Let's get the GCF of the left-hand side and the GCF of the right-hand side. So on the left, I have x cubed plus 2x squared, x squared. Okay, and then I'm just doing the same thing over, right? Divide every term by x squared, x plus 2. Great. On the right-hand side, what is it starting with? Negative. It's a negative 2x minus 4. When it starts with a negative, you need to bring the negative out. Negative 2, right? Divide everyone by negative 2, and you get x plus 2. Did I do this right? Yeah? How? How do you know? Good, because your parentheses are the same. So then now your final step is double parentheses, x plus 2, and then x squared minus 2. Yeah? All right. Okay, let's go on to the next one then. Number 3 and 4, or numbers 3 and 4. Okay, so 3, I have 4 terms again. Do I have a GCF for the whole thing? No. So divide this in half, and then let's GCF factor both sides. So on the left, you should have 5x squared. Yes?
Yep.
Okay.
Then it gives you x minus 4.
X minus 4. And then on the right-hand side, 3x minus 12, what's my GCF? 3. And then x minus 4. So perfect, we did that correctly. at number 4. Yes. I have 1, 2, 3 terms. Whenever I have 3 terms, this is that T-chart way, right? So this is going to be AM. Look at the whole thing. Do I have a GCF that I can bring out? No, right? Okay, so I want 2 numbers that multiply to give me a positive 8 and adds to give me a positive 6. Okay, 2 and 4. Good. 2 times 4 gives me 8, adds to give me 6, right? This is just the plain old x squared, right? I don't have a number in front. So that means I can go straight into my double parentheses. They both get an x, right? What kind of 2 do I have? So plus 2. What kind of 4? And then look, you're done. That's it. That was so easy, right? Good. All right, so let's look at 5 and 6. So they're getting a little bit more involved. Look at number 5. 1, 2, 3. This is a trinomial. So I know this is going to be another AM. Here's the thing, though. Couple things here. It's starting with a negative, so I know I need to bring the negative out. Does it also have a GCF? Like a number GCF? What is it? 2. So you have to bring negative 2 out. Can I take out an x? No, because 24 doesn't have an x, right? Okay. So I'm going to divide everyone by negative 2. Then I have x squared plus 4x minus 12. Yes? Okay. So now I just have to bring down my AM down here. Right? If you take a GCF out, this guy is just going to wait. It's going to wait until you're done. All right, so let's see. 2 numbers that multiply to give me negative 12 and adds to give me a positive 4.
Negative 2 and 6.
Oh, negative 2 and 6? Sorry. Sorry, I know. Right? So negative 2 and 6. This is just a plain old x squared, so we could go straight into our double parentheses, right? X what? Minus 2 and x plus 6. Don't forget to bring down GCF, negative 2. Okay. And you know what, guys? Say I was rushing through my homework because I didn't have it done and I was trying to do it before the bell. No, because you guys wouldn't do that.
Sure.
If you wanted to make sure that you factor this correctly, what could we do? FOIL, double distribute, good, good. You can multiply this back and you should get your original expression, yeah? It is a lot of time, but that's why you shouldn't rush through your homework, right? But if you want to check. All right, so let's look at number 6. 1, 2, 3. I have a trinomial, but we're getting better at this GCF thing. That looks like it has a GCF, doesn't it? Yeah. What is it? 5x? Great. 5x. All right, so if I divide everyone by 5x, I get x squared. 36? Is that right? 3, 6, yeah, right? Oh my God. Okay, so AM. T-chart, yes. 2 numbers that multiply to give me negative 36, but add to give me negative 5.
4 and negative 9.
Okay, negative 9 and 4. Wow, you guys are really good. All right. This is just a plain old x squared, so again, I can go straight into my double parentheses, and then it's x what? Minus 9 and x. Okay, what did somebody say about the GCF? Bring it down, don't forget. 5x goes in the front. Right? Don't be like Miss Osborne when I accidentally, on purpose, didn't bring it down last class, right? Accidentally on purpose. Okay. Let's look at number 7 and 8. So I have 1, 2, 3. Okay, this is another AM T chart, right? Here's the thing though, guys, I see a number in front, but there's no GCF. 5, 3, and 2, the GCF is 1, right? And I can't take out a Y because they don't all have a Y. So remember what we do when we have a number in front, we need to multiply it with our C number, right? So what's 5 times -2? Okay, so that's my new M number, -10. And my A number stays the same. What's my A number? 3. Okay, guys, two numbers that multiply to give me -10, 5 and -2. Good. All right, so now, whenever you do the swing way, you have to bring down the first, and you have to bring down the last from your original, okay? All right? And then you're going to rewrite your middle term, this plus 3y. You're going to rewrite that using the two numbers that you found in your T chart, okay? So plus 5y, don't forget the variable, okay? And then minus 2y. Yes? Okay. So now how many terms do I have? 4. What do I do when I have 4 terms? Yes, divide it in half. When you have 4 terms, you're going to divide it in half. And then GCF factor both sides, right? Okay, so let's do this. 5y. y over 5y gives me 1. Okay? Don't just throw that term away. It has 1. -2y minus 2. What's my GCF? -2. It's starting with a negative. Make sure you bring that negative out. And then y plus 1. We did this right. Right? You guess why. Your parentheses match. And you know what? It doesn't matter which order you put them in, right? You can put the y plus 1 first or second. Okay? All right, let's look at number 8. What's my GCF here? 2. All right, so after I take out the GCF, I still have a number in front of my a squared, right? And this is a trinomial, so I know that this is AM. All right, that's fine. I can take this 2, swing it over, and multiply it with a -5, right? So now my M number is good, and my A number, -9. What two numbers multiply to give me -10, adds to give me -9? Yeah, -10 and 1, right? All right. So we're going to let this guy wait. The 2, the GCF, you're going to bring down the first, bring down the last. So 2a squared comes down, -5 comes down. Rewrite the middle term using the two numbers that you found, right? -10a plus 1a. And then the same thing that we just did, right? Factor by grouping. Divide it in half. One a minus 5. What is my GCF? 1. I mean, you have to bring something out. If 1 is the only thing, bring it out. Don't forget to bring down your GCF. And here we go. Okay? Questions about this? All right. Good. All right, then you know what? I want to look at the homework. Okay, so homework problems 4 and 14. So number 4, you have 1, 2, 3, 4 terms. Means we need to divide it in half. There's no GCF for the whole thing. So on the left-hand side, my GCF is p squared. Now I have 2p plus 5. Yeah? On the right-hand side, we have 6p plus 15. 6 and 15, your GCF is 3. So that's 2p plus 5. And I know I did this right because my parentheses match. So I have 2p plus 5 and p squared plus 3. There you go. Okay? And number 14. So I have 20x squared plus 3x minus 2. I have 3 terms, so I know that this is a t-chart. But I have a number in front of the x squared. There's no GCF. So this tells me that I need to swing it over and multiply. So now my new m number is negative 40, and my a number is a positive 3, right? Okay, so what is this? 10, 4 is not it. 22 is not it. What do we have? 8, 5? 8 and a negative 5. That gives me 3. So I have to bring down the first, bring down the last, and then rewrite the one in the middle, the 3x, using the two numbers. So you know what? I'm going to switch this and say minus 5x plus 8x. Okay? You can write it in any order, right? As long as you use the two numbers. All right, so now I have 1, 2, 3, 4 terms, GCF factor. On the left side, I have 5x. So I have 4x minus 1. On the right-hand side is 2. So I have 4x minus 1. And there we go. I have 4x minus 1 and 5x plus 2. No GCF to put in front, so there we go. Okay? Questions? All right. All right, so the reason why you guys have this is because it's going to be helpful in your factoring adventure, okay? Especially for today's factoring lesson. We're going to talk about perfect squares and perfect cubes. This should not be new, right? But sometimes we forget if we haven't used it in a little while, I guess. I don't know. Let's go over these together. What is 1 squared?
1.
1. What's 2 squared?
4.
3 squared? 4 squared? 5 squared? 6 squared?
36.
7 squared?
49.
8 squared?
64.
9 squared?
81.
10 squared? 11 squared? 12 squared? 13 squared? Good. 169. And 14 squared is?
20.
You just split these two. 196. 15 squared is? 20 squared. All right. Good job. Okay. All right then. Perfect cubes. 1 cube. 1. Listen, 1, anything to the power is 1, right? Okay, don't you tell me it's 3.
3.
All right, what's 2 cubed? 8. That's 2 times 2 times 2, right? Not 6, 8. Okay. 3 cubed.
27.
Good. 4 cubed.
64.
Good. 5 cubed.
125.
Perfect. 6 cubed.
216.
7 cubed. 343. 8 cubed. Oh, do I? I do. I know this because
8
I just
cubed
use
is
it all.
512.
8 cubed is what? 512. 9 cubed.
729.
And 10 cubed.
1,000.
1,000. Good.
10.
Guys, not saying you need to memorize it. Don't have to memorize it, but if you do, I think it might help you out with the factoring binomial stuff that we're going to do, okay? So, and the thing is, you guys are going to be factoring so much, you probably will memorize this without even trying, hopefully, okay? So, there we have it. If you want to keep it out as a reference while we're doing this, please feel free to, okay? All right, so let's go on to our notes. We're going to talk about binomial factoring today. What does it mean if we have a binomial?
2.
2 terms. Good job. Look at that. Oh, no. There we go. 2 terms. There. You good? And remember, the first rule of factoring is what? GCF. Can you see it? Greatest common factor, GCF. Okay. All right, so the first binomial method that we're going to talk about is called difference of squares. Okay? Question for you. When you hear difference of squares, like what do you think of? What does that sound like? What? Subtraction. Good. All right. Because it says difference, right? Okay. So you need them to be subtracting. Your 2 terms have to be subtracting because it's a difference, right? Difference of what? Squares. Oh, so perfect squares. Right? And then the last thing that you need for this difference of squares is you have to have 2 terms. You can't do this if you have 3 terms. Okay? Okay, that would be a trinomial. All right, so we've come up with a little way for you guys to remember. Yeah. You know, if you abbreviate difference of squares, it's DOS, right? Difference of squares. Okay. And it's just so long for me to say difference of squares every single time. If I refer to it as DOS, then you guys are going to know what I'm talking about, right? Yeah, you do. All right, so what do we do? Well, difference. Okay, B, what is this? Double parentheses. Okay, I'm going to shorthand it. I'm not going to write out parentheses. So that's double parentheses. That means we have this, double parentheses, right? Okay. O, opposite signs. All right, opposite signs. So inside your double parentheses, you're going to have 1 plus and 1 minus. Opposite signs. And squares. You need to take the square root of each term. Okay? 1 plus, 1 minus. Here's my example right up here. X squared minus 25. What is the square root of x squared? X. And that goes in the first spot because x squared is in the first term, right? What's the square root of 25? 5. There we go. X plus 5 times x minus 5. Okay? So that's like a little Cliff's Notes version of that. But, guys, think about this. Why does it come out to be this? X squared minus 25, isn't it really x squared plus 0x minus 25? Right? Because you don't, your middle term is 0, right? So you could do AM, right? Two numbers that multiply to give you negative 25, but add to give you 0 is what? What two numbers multiply to give you negative 25, but add to give you 0? Negative 5 and 5. So look at that. That's what we have here. X plus 5 and x minus 5. Okay? All right. But, you know, normally when you see a binomial difference of squares, that's the easy, quick way to do it. Okay? All right. So let's look at our examples here. Number 1, x squared minus 49. All right, do I have a GCF? No. Is this a perfect square? X squared?
Yes.
Is 49 a perfect square?
Yes.
Okay, so double parentheses. Opposite signs. Yep. What's the square root of x squared? What's the square root of 49?
7.
There you go. You're done. X plus 7 times x minus 7. And if you double distribute or FOIL this, you'll get x squared minus 49. Okay? All right. Let's try example 2. So, okay, now I have a number in front of the x squared, right? Do I have a GCF? 4 and 81? No, right? But, look at this. Is 4 a perfect square?
Yes.
Yes. Is x squared a perfect square? Yeah. What is the square root of 4x squared? 2x. What's the square root of 81? So, you know what, guys? Double parentheses, opposite signs. What goes in the first spot? 2x. What goes in the second spot? The 9. Good. So if you have a number in front, okay, if you have a coefficient, it's okay if it doesn't GCF out. If it's a perfect square, you can square root it, right? I'll just go right in. There. Let's look at example 3. X squared plus 144. Thoughts?
Yes.
No solution. Why? Because it's plus. Is this a difference? No, this is the sum, right? It's not a sum of squares. This is prime. We don't even have a GCF we can take out of it. So this is a prime. Okay. And if you need to, please make a note for yourself so that later on when you go and review these notes and you go, wait, why is it prime? Because Elise said this is not subtracting, it's not difference. Okay. All right, look at example 4. What is this? Not prime. I see what you mean though. It is adding, but it's not prime because what can you do? There's a GCF, yes. Take out the 2. And then like we just said, right? This is plus, so you can't go any further, bless you. So this is it. Okay? Questions? All right. Okay, so let's look at example 5. You know, I see the subtract, So I go, okay, maybe this is dose, but I can't because x cubed does not, right? That's not a perfect square. What's the first step in factoring? GCF. What is your GCF here? X. So then you have x squared minus 9. Can you keep going? Can you dose inside the parentheses? Yes. X squared is a perfect square, 9 is a perfect square, and a subtract. So double parentheses, opposite signs, x plus what? And then x minus, and then don't forget. All right, good job. All right, how about this? You know, at first glance, if I looked at this, I go, oh, those numbers are so big. Maybe they have a GCF. But you guys know your perfect squares, right? You look, what is the square root of 169 x squared? 13 what? Yeah. No, what? 13 what? X. Right? How about 196? It's 14. So double parentheses, 13x plus 14 and 13x minus 14. Questions? All right. So let's go to the back then. So that was difference of squares. Now we're going to look at perfect cubes. Okay? Yes. So the sum and difference of cubes. What does that mean to you? Adding and subtracting with what? Cubes. So perfect cubes. Okay. So this is different from dose in that you can have plus, right? It's not just subtract. Okay. Two things. Again, two terms. Right? You can only do this with binomials. All right. And then the second thing, well, you have to have perfect cubes. And then in parentheses, we'll say plus or minus, right? They can be adding or subtracting. All right, so with this, okay, this factoring is just a little bit different from the other factoring you've done, okay? This has a pattern that you have to follow. So with this one, okay, I'll refer to this as the SOAP way, okay? And what does that stand for? Same, opposite, always positive. Okay? Same, opposite, always positive, or always plus. Okay? Okay, so what do we do? Well, I'm just going to lay out everything and then we'll do the example. Okay? So it follows this type of pattern. You're going to have a binomial and a trinomial together. Okay? So you have two parentheses for this, but the first one only has two terms. The second one has three terms, okay? Now, if I go, actually we'll do it this way. I think it'll be easier this way. Okay, so what I need to do is I need to take the cube root. So I'll do this, cube root. All right? Maybe if we draw it in there, it can kind of help us remember. Inside the little parentheses, the binomial, I need to take the cube root. So if I look over here at my example, x cubed, what's the cube root of x cubed? X. Right? You don't have to draw those lines. I'm drawing those lines right now so that they're reference. Okay? And then guys, what is the cube root of negative 8? Negative 2. Right? All right. So then what do we do now? After you fill in your binomial, you need to fill in your trinomial parentheses. And the first one is your first term squared. Okay? First term squared. So look at your first term in your binomial, your x, right? What is x squared? X squared, right? Now that middle term is your first and your second multiplied. Although, you know what? When you multiply it, don't multiply the sign, okay? I shouldn't have put the sign there so early, but okay. X times 2 is what? 2x. All right? Sorry, just bear with me. Okay. And then this last one is your second term or your last term squared. Okay? So then look at the 2. What's 2 squared? What's, yeah, 4. Right? Are we okay so far? Yeah. Okay, so I'm going to do that now. Okay, if you're ready for the signs, okay, good. So this is where the SOAP comes in. Same, opposite, always plus. This sign is the same as your problem. I know this one's a long one. Same as your problem. So minus. What's the opposite? Plus. And the last one is always positive. Okay? So that same opposite, always positive, that goes for the signs. All right? This one's the weird one. It's kind of weird, right? It's really weird to teach it, too. All right, let's try some examples. Yeah? Wow. Oh, here's the other thing. This trinomial, don't you kick that desk. You can't factor it anymore, okay? So don't try to T-chart factor that. That's done, okay? That one's prime. All right, so just a note for yourselves. Don't sit there trying to factor it out. You can't. I'll write this. Can't factor any further. Okay? All right, let's try an example. Oh, and see, look, here it lays it out for you again, just in case. So we have x cubed plus 64. Let's do this. Okay. So what's the cube root of x cubed? Huh? X. What's the cube root of 64? 4. So now the first term in your trinomial is the first one squared. So that's x squared, right? That guy. Your middle one is these two multiplied each other. What do you get? 4x. And then your last one is this last one squared, which is 16. Good. And then you have, so, same as that, which is what? Opposite, always positive. Okay? How is that? Yeah? Any confusion right now? Do you have any questions about this? Okay? Let's try this one. 125 x squared minus 1. What is this? Is this in the review? Okay. What does it say? X cubed?
Yeah, first.
Oh. I was like, they go to... All right. So this is a binomial, right? And if I see x cubed, that gives me a big hint. Okay, maybe this is a SOAP way, right? Is 125 a perfect cube? Yes. Is 1 a perfect cube? Yes, right? All right, so I'm going to set up my parentheses, well, because I also don't have a GCF. So I have a 2 and a 3, right? What is the cube root of 125x cubed? 5x. What's the cube root of 1? 1. What goes in the first? So it's 5x squared. That means it's 5x times 5x, which is what?
10. No, I'm sorry, 25.
25x squared. Okay? Please remember that the 5x is in parentheses, so you have to square everything, right? So this middle one is 5x times 1, right? The 2 multiplied 5x. And then the last one is 1 squared, which is? Now for your signs, same, right? Opposite, always plus. Okay? All right. Yeah.
Why did we choose 1 for the last term? Isn't it the second term that gets?
Yeah, which is this.
Oh.
Right?
Okay.
All right, so let's try example 3. You know, I do have 2 terms, but it says x to the 4th. Do we have a GCF? Yes. What is it? 2x. So we have x cubed plus what? 1,000. All right, you guys try this. Okay, so for this one, you should have yes?
Yep.
Did we all get that? Did I do it right? Cooper? Yeah? All right. Let's try the next one then. X cubed minus 3. Huh. Wait a minute. It's a binomial, and x cubed is a perfect square. I mean, perfect cube, because that would be an x. But wait, is 3 a perfect cube?
Nope.
No. Do they have a GCF? No. So what is this? Prime. Okay. How about this one? this one. GCF for the whole thing? No. So, all right, I'm gonna go set up my, my cubes, my cube root. Okay, so let's see, 512x cubed. What is that? What's the cube root of that? 8x. What's the cube root of 27? 3. So what did you guys put for the first term in the trinomial? 64x squared? 8 times 8. What about for the middle term? Huh? Oh, what is 8 times 3? 24x. You gotta multiply the 2 for the one in the middle, right? And what about the last? 9. All right. Yes, Hannah? You found it? Okay. What do I do with the signs? Good. So, right? Same as that one. Opposite. Always plus or always positive. Yes? This is where we see a lot of mistakes. If there's a number with that x, you have to square that number as well, okay? Not just the x. All right, let's try this one. Okay, you guys try this one too. Get me started. Okay. I'll set up the parentheses and you tell me what to fill in, okay? All right. 6x plus 5, 36x squared minus 30 plus 25. You know what? I like it, but you left out one teeny tiny little thing. Who can, yes, Yule. X, yes. Dylan, you know what? I'm sorry. You know what it is? Because I know. Okay. X. Don't forget the X. Don't forget the X. Because if you do not put the X, then why can't I just combine negative 30 plus 25? And then now we're missing a term, right? Okay. Good job. Great job, guys. All right, try this one, please. Ooh, this one is... I can just look at it right away and go, wait a minute, this one has a GCF. Does it?
Yes.
No? Ooh. Well then, if I look at this and I go 24 and 375, is there a GCF? Well then, I could go into my calculator.
What if there's no cube?
And I can go to math, number, GCD. What was it? 24, comma, 375. Right? This is how I can check and see if there's a GCF. Oh, they do have a GCF. 3. And they both have an X. So an X can come out. 3X. Right? Yeah. So that's 8x cubed minus, what is this? 1, 2, okay, 125. Right? And then can I soak it inside? Yeah. Right? So don't forget to bring down your GCF. And you know what? I'm going to do that right now because, should, so you don't forget. What goes inside the binomial? 8. Okay, well, what's the cube root of 8x cubed? 2x. What's the cube root of 125? All right, now what goes in the trinomial? What's the first term? 4x squared. What's that middle term? Huh? What is this? What's this times that? What's 2x times what? 10x. And what's the last term? 25. So my signs minus, plus, plus. Good. Same, opposite, always plus. Is that it? All right, so I have a couple problems for you.